Hello all, welcome to the next video of the chapter Electricity. In this video, we will revise series and parallel connection of resistors through some numerical problems. So without any further delay, let's move on to the first question. Three resistors of resistances 4 ohm, 6 ohm and 12 ohm are connected as shown here. What is the equivalent resistance of the combination? Also, calculate the current through individual resistors and total current in the circuit. So, from the circuit given, it's understood that resistances R1 is equal to 4 ohm, R2 is equal to 6 ohm and R3 is equal to 12 ohm. And the arrangement of resistors are in such a way that they are parallel to each other. So, in a parallel combination, equivalent resistance is found out by adding the reciprocals of the individual resistances. So 1 by Rp, where Rp is the equivalent resistance in a parallel circuit, is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So substitute the values 1 by 4 plus 1 by 6 plus 1 by 12. So you can have the LCM. Find out the LCM for 4, 6 and 12. So the LCM of 4, 6 and 12 is 12. So now let's see how to divide. So 12 divided by 4 is equal to 3 plus 12 divided by 6 2 and 12 divided by 12 1. So the fraction becomes 6 by 12, which is 1 by 2. So 1 by Rp is 1 by 2, hence Rp is equal to 2 by 1 or 2 ohms. Now in a parallel circuit, current flowing through each resistor is different. That means we have to find the individual current flowing through R1, R2 and R3 and then sum it up to find the total current in the circuit. So, in order to find I1, I2 and I3, we have the formula I is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. Now substitute the values. V by R1 6 by 4, 3 by 2 and 1.5 ampere. I2 V by R2 6 by 6, which is 1 ampere, and I3 V by R3 6 by 12 is equal to 1 by 2 is equal to 0.5 ampere. Now the total current will be I1 plus I2 plus I3. So 1.5 plus 1 plus 0.5, which is 3 ampere. You can also find the total current if you take V by total resistance, that is 6 divided by 2, which is again 3 ampere. Moving on to the second question, three resistors of resistances 12 ohm, 15 ohm and 20 ohm are connected as shown here. What is the equivalent resistance of the combination? So let's analyze the diagram given here and understand whether the resistances are connected in series or in parallel. How do you think the resistances are connected? In order to understand the connection of resistances, take the path of the current flow through R1, R2 and R3. So if you see, the current I gets split up into I1, I2 and I3 when it passes through each resistor. That means resistors are connected in parallel to each other in the given diagram. So when resistances are parallel to each other, equivalent resistance is found by adding up the reciprocal of individual resistances. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Substitute the values 1 by 12 plus 1 by 15 plus 1 by 20. Find out the LCM. Why are we going for an LCM method? Because there are three denominators and all the three denominators are different from each other. So we have found out that the LCM of 12, 15 and 20 is 60. So 60 divided by 12, 5 plus 60 divided by 15, 4 plus 60 divided by 23. So 5 plus 4 plus 3 will become 12 and the fraction becomes 12 by 60. So on simplifying, 12 by 60 will become 1 by 5. So 1 by Rp is equal to 1 by 5. So effective resistance or total resistance Rp is equal to 5 ohm. Next question, calculate the effective resistance between point A and B in the following circuit network shown here. So you can see a network here Between A and B, there are three resistances R1, R2, and R3, where R1 is 1 ohm, R2 is 2 ohm, and R3 is 1.5 ohm. If you clearly analyze the circuit, you can understand that R1 and R2 are in series. So, the effective resistance of R1 and R2 can be found out by adding R1 and R2. That will become Rs is equal to 1 ohm plus 2 ohm, which is 3 ohm. This effective resistance is in parallel with R3. So now the total resistance will be 1 by Rp is equal to 1 by Rs plus 1 by R3, where Rs is the equivalent resistance that we found in the previous step. So 1 by 3 plus 1 by 1.5, cross multiply and do the fraction. So 1.5 plus 3 divided by 3 into 1.5, which is equal to 4.5 by 4.5, which is 1 ohm. So 1 by Rp is 1 ohm. So the total resistance of the circuit is 1 ohm. Now here comes another circuit with 5 resistors. So here R1 is 3 ohm, R2 is 2 ohm, R3 1 ohm, R4 3 ohm, and R5 2 ohm. Let's analyze the circuit. If you see in the circuit through arms A, C and B, R1 and R2 are in series. So add the values and find the equivalent resistance in that point. So it will come to 5 ohm. Similarly, in the arms A, D, B, the resistors R4 and R5 are in series. Again add them up and you get an equivalent resistance for that part of the circuit also. Now these two values, these two effective resistances are actually in parallel with the resistor connected in the length AB. So the two equivalent resistances and R3 are in parallel. Let's find the effective resistance by using the formula 1 by R is equal to 1 by Rs plus 1 by Rs plus 1 by R3. Why Rs and Rs? Because that was the resistors present in AC, CB, AD and DB. We have found the equivalent value and now we are going to find the total resistance of the circuit. So 1 by 5 plus 1 by 5 plus 1 by 1. 1 by 5 and 1 by 5 will become 2 by 5 plus 1 by 1 and you will get the value 7 by 5. So effective resistance will be 5 by 7, which is 0.7 ohm. So here comes an homework for you. Calculate the effective resistance in the following circuit network shown here. So there are 4 resistances connected in this circuit. Find out the total resistance of this circuit and drop your answers as comments. Thank you for watching this video. I hope that you have understood how to calculate the effective resistance when a combination of resistors are given, whether they are combined in series or in parallel. Do copy these sums discussed in this video to your classwork and show it to your science teacher. If you like this video, please hit the like button and share the video among your friends and family. Subscribe the channel for more videos of class 10 chemistry and physics.